Hello and welcome to a new series of our online seminars. My name is Konstantin Hüdepol. I'm working for Softing IT Networks. I'm product manager and responsible for the global product management of the handheld testers. I have a colleague with me today to help me, Alexander Boy.
Hello.
Introduce yourself.
Welcome to our webinar today. My name is Alexander Boy. I'm working also for Softing IT Networks as product manager for the handheld testers.
Okay, Alex will handle our chat today.
Yes.
If you have questions, Alex will collect all the questions and will then present all the questions at the end.
Correct.
We'll try and answer everything. You also, on the sidebar, you have some files you can download during the meeting or after the meeting. And at the very end of the meeting, there's a very small questionnaire. It would be great if you could fill out the questionnaire to help us to improve these seminars. All right, let's dive into the program.
Okay.
And let's start. Thank you, Alex. Topic of today, standards update 2021. So we'll talk about what's new in standards, what's different, and how does that have an influence on our cable testing products. So first of all, we'll take a very short look about who is Softing. We take a look at the standards for structured cabling. We look at cabling configurations and cable certification. We also have a very short look on remote powering because that also has an influence on cable testing. Take a short look on Ethernet speeds versus cabling standards. And then I'll give you a short outlook and we run the question and answers with Alex. All right. Who are we? Softing is a management holding company. We are a medium-sized company. Our headquarters is near Munich in Germany. We are founded in 1979. We went public in 2000. Our turnover is around 90-some millions. We have around 400-some employees every year and quite a few locations, which I'll show you later. Basically, we have three business units: the automotive, IT networks, and the industrial team. The automotive team, they basically have software for the diagnosis in cars. The industrial team, they have software and hardware for industrial automation. And our team, obviously, we have network measurement products, cabling measurement products. So our testers, we have a quite big range of handheld testers with the flagship, the Wire Expert series for cable certification, the Fiber Expert series for as an OTDR for fiber certification, the Network XG series speed qualifiers for up to 10 gigabit, Cable Master series, small handheld wire map testers and network troubleshooting testers, Pinger Plus, Pinger Pro, IP network testers. Cable trackers is tone and probe sets. The LAN Expert is a gigabit network analyzer, and also on wireless LAN we have products for wireless LAN sniffer and site survey products. So quite nice range of test products for today's networks. Where are we based at? You see in Munich here is our headquarters. We are in London, Paris, Milan, Vienna in Europe. We have quite a big subsidiary in Knoxville, Tennessee. We have a sales office in Shanghai and in Singapore, where in Singapore is also the development of our handheld certifiers. So if you look at wiring, the basic challenge is if I can quote a Pericles, a Greek statesman, the important thing is not to predict the future, but to be prepared for the future. Cabling is the networking product that lasts longest in a building, so you need to prepare for future use. If you look at the PCs only have a mean lifetime in offices between 3 and 4 years, in homes 3 to 8 years. Servers and offices have a medium lifetime about 5 to 6 years. In RZ means data centers, and data centers between 3 and 5 years. But the cabling in offices lasts minimum 10 to 15 years. in a data center 7 to 10 years, and in homes even up to 20 years. So to be prepared for the Ethernet speeds that will come in future, you have to also think about the cabling and how the cabling can survive long as possible. If you look at Ethernet speeds, well, the up to 1 gigabit, that was in time frame below the 2000s. So Ethernet started with 10 base T around 1980, came to 1 gigabit in the year 2000. So that was what I would call today slow speeds. Now in the 2010s and up to 2020 now, quite a few new speeds arrived: the 2.5 gigabit, 10 gigabit, 25 gigabit, and even 40 gigabit on copper cabling. And on fiber cabling, we talked today already about at least 400 gigabit. So in IEEE, they started now even requests for projects for beyond 1 terabit actually. So quite a dramatic development of speeds in the last years. And if you now think about your cabling really has to support a lot of new things. Some wiring examples. So that if you want to know how bad wiring looks at, take a look at Pinterest. There's quite a really bad examples about bad wiring. This happens when you don't look at standards and just do wiring as you like. So cabling standards are really the key to success, to keep your wiring fit for the future and safe for the future, basically. If you look at standards, there are standards for applications. In our world, the IEEE application standards are the important standards. 10 gigabase Ethernet, 10G base Ethernet, for example, is one of the very important ones. And then you have the passive infrastructure standards. So with our certifiers, we really look at the passive infrastructure. So there you have cabling standards, component standards, and measurement standards. By the way, the measurement standards, that's where the certifiers are defined. So that is basically what we call our Bible. That's how our testers work. In the field, you don't really see that. In the field, you really see the cabling standards. And sort of in between, you also have the installation standards. They tell you how to install cabling. In today's session, we don't really look at the installation standards. We only look at cabling standards and how to apply that on handheld testers. So move on. Yeah, if you look at the standardization, there's a global standardization and European standardization, and also local. So in Germany, that would be the German standardization bodies. Every country has its own, basically. From a global point of view, ISO-IEC is the dominant standards body. The IEC 14763-2 is the standard that defines the installation practices. And ISO 11801 is the series of standards that define cabling, basically. In Europe, the standards body is the CENELEC. The EN50174 is the standard for installation practices, and the EN50173 is the standard for cabling. Basically, the ISO 11801 and the 50173 are, from a testing point of view, they are basically the same limit sets, the same criteria, and so on. The wordings are different and some of the details are different, but from a testing point of view, they are basically the same. And then on local, we have the DIN standards. So in Germany, the right one would be the DIN VDE 0800173 series. And basically, again, it's the same like the EN50173. Why do I also have the TIA standards here on this picture? This is because you see a lot of TIA 568 references on products. So a lot of people in Europe also think that they have to test according to TIA standards. That basically is not recommended by us. You should only use the TIA standards when your customer, your client, really specifies that. For example, if you test in an army base or if you test in an American hotel chain, they might really specify to test against TIA limits. But other than that, you should not use that in Europe unless it's really specified. So I stand in front of it so you don't see it anymore, kind of. All right. Coming back to standards, so without the standards, really nothing in our modern world would work anymore. Vehicles, electrical appliances, telephones, credit cards, all works on standards. As I said before, in Europe, the key standard for cabling is the EN50173, and in fact, it has 6 requirements or 6 standards, same like the ISO 11801. So that's why I have here the ISO 11801. The dash one is the general requirements. This is requirements that apply to all the in-house cabling. In the dash one, you find all the limits. So if you look at its standards in our testers, they always refer to the dash one, to the 11801-1 or to the 50173-1. The dash two then has requirements for office cabling, office buildings. The dash 3 has requirements for industrial use areas. The dash 4 for homes. The dash 5 for data center areas, and the dash 6 for distributed building services. But also these other parts of the standard, like the dash 6 or dash 5, they always refer, when it comes to limits, they refer to back to the dash 1. So you find all these test cabling standards, of course, in our testers. But before we go there, let's take a little bit more look. We have cable standards like the EN50173 series. We have component standards like the 60603-7 series, for example. You don't find those in testers because we don't test cables as such or connectors as such. We always test the cabling, and that is, as I said before, in the 11801 or EN50173 series. And you also see here again the installation standards, the ISO IEC 14763-2 or the EN50174. Then I also have here some technical reports. There was, in the past, there was a technical report that was quite interesting, the 11801-9901. That was the first one to define 40 gigabit cabling. That is not needed anymore because 40 gigabit cabling basically is now category 8 cabling, which is now in the 11801 or 50173. But still valid is the 9902 for end-to-end link cabling. So I'll explain later on what end-to-end link is. That's an interesting configuration for industrial use, for example, or for sometimes also for building automation as well. The 9903 you don't find really in the cabling world. This is only modeling that defines the mathematical models for permanent link and channel links or other configurations. The 9904 is cabling to support 2.5 and 5 gigabit Ethernet. That is interesting today for so-called N-based-T applications where switches are deployed into legacy Cat6 or Cat5 cabling. 25 gigabit Ethernet in the dash 9905 is interesting because that is a special standard how to support 25 gigabit. That becomes more and more interesting now. And also the 9910 MPTL, modular plug terminated links. What a modular plug terminated link is, I will come back to that later on in another slide. So on the testers again, in the certifiers you find the cabling standards. but also you can find in other testers IEEE standards. That is in our qualifier series. In the qualifiers, they test they test if gigabit Ethernet or 10 gigabit Ethernet works according to IEEE. Good. So if a bit more deeper look into cabling, so we have different bandwidth. That by the way is more or less the same or across all the world. So we come to that. In the up to 500 megahertz, we have the TIA 568, category 5E, category 6, category 6A in America. Again, don't use that in Europe. In up to 600 and even 1000 megahertz, we have the ISO 11801. In the old version, the second edition only went up to 1000 megahertz, up to class FA. And same in Senelec, we have the EN50173 and 100 megahertz class D, 250 megahertz class E, 500 megahertz class EA, 600 megahertz class F, and 1000 megahertz class FA. So that was basically valid until 2018. And after 2018, sorry, I forgot the DIN ones there. Same thing again, sorry about that. And after 2018, the 2000 megahertz bandwidth was added in TIA with the category 8 and in the ISO and EN standards with the class 1 and class 2 cabling. Class 1 cabling is cabling up to 2000 megahertz on RG45 components, similar like the TIA category 8. And class 2 cabling is cabling to up to 2000 megahertz with non-RG45. Well, so that means like with Terra connectors, ARG45 or GG45 connectors. So again, don't think so much about the American standards, leave them apart unless you really need them. So why do we have categories and components? I want to go to that topic a little bit more in detail. If you look at a link, the link consists of many different items. You have, if you start from the very left, you have connectors, then you have a patch cable, then you have again a connector, then the socket of your link, you have the cable of your link, then again a socket, and so on and so forth. So you can mix all these categories. For example, the patch cable has category 5E plugs here. The patch cable has category 7A cables, so up to 1000 megahertz. And the sockets of your permanent link is a category 6 socket with 250 megahertz. And the cable is the super high-end cable category 8.2 up to 2000 megahertz. So what happens if you now assemble all these things together? Should have done that before, sorry. Okay, now I have built a patch cable and a permanent link. The patch cable is still a category. It's a category 5E patch cable. Why is it category 5E? You have used a 1000 megahertz cable because the connectors at the end of the patch cable are only 100 megahertz connectors. So they slow down the whole thing down to category 5E. Same on your link, your category 6 sockets slow down your link to a class E link up to 250 megahertz. So the very nice category 8.2 cable you have used in this example is not really used anymore here. It's only a class E link. Now I plug everything together. I plug my category 5 patch cords into my class E link, and I get only a class D channel anymore. Why? Because again, my category 5E patch cord slowed down my link to 100 megahertz. So that happens when you mix components. Be careful what you mix. So because the weakest part of the whole assembly slows down your whole assembly. And that's how classes and categories work together. So I hope this clarifies a few things. Let's move on. If you look at structured cabling, we have cables in between buildings. That is the primary cabling, the campus cabling between mostly in fiber optic, single mode or multi-mode. Nowadays, not so much anymore in copper. Then you have the secondary cable, that's the backbone or riser cable, mostly today in multi-mode or single mode, sometimes also copper, but mostly multi-mode, single mode. And of course, then the tertiary cable, the horizontal cable, mostly today in copper. There's versions with consolidation point or without. Why is copper used here predominantly? Has basically two reasons. One reason is cost. Copper cabling horizontally and the network interface cards in copper are just far less expensive than fiber. And the other reason is power over Ethernet. Power over Ethernet is very popular today. Many applications run on power over Ethernet nowadays. Most of the modern phones, for example, are power over Ethernet phones. So that runs perfectly nice on copper cables. We have a fourth thing, which we shouldn't forget, is wireless LAN. So IEEE 802.11n runs up to 600 megabit per second, and the new AC up to 1.3 and 1.7 gigabit per second. Wireless LAN, modern wireless LAN, is a big driver for better cables because the access points, they nowadays need high-speed links, uplinks to the next switch. So in terms of cables, wireless LAN is really a driver of high speed. So let's look at the cabling configurations. Permanent link is the link that everybody installs. So what the permanent link can be just the fixed cable on a backbone, for example, as I said, from one floor distributor or to the next one. From the horizontal wiring from the floor distributor to the workplace, or from the floor distributor to a consolidation point, or including also from floor distribution consolidation point up to the workplace. What do I mean with these dotted lines you see here in the picture, these two dotted lines over there? These are the reference planes for testing. That means that the first and last connector of the link have to be included in testing. That is always a challenge for the tester, that they accurately measure the first and last connector. So in the past, in the old versions of EN50173, 5173 and 11801, these configurations were called PL1, PL2 or CP1, and the one up to the consolidation point was called PL3. In the and you measure that with cables, of course. And in the new configuration, the PL1 in the new standards from 2018 on, the PL1 is now called in ISO a 2-connector link, and in EN the configuration A. And the PL2 in the ISO world was also called 2-connection, or is also called 2-connection link. In EN, it's called configuration B. And you get it, sort of. The CP link is now also a 2-connection link, and in EN is configuration D. And guess now the one with the 3 connections is now in ISO called the 3-connection link, and in EN the configuration C. I personally prefer the way ISO calls the links because that's more obvious, 2-connection, 3-connection. The EN guys were a bit more formal and you choose to use configuration A to D. You can find all these things in our testers, as you see up here in the picture. All the new standards are, of course, implemented in the tester. So a lot of changes here. In channel is the permanent link and all installed cables, patch cables. The good news here is that they all the different versions with consolidation point, with cross connects and so on, they have all one limit, because the standards basically say, doesn't matter what's in between, it has to work from first connector up to last connector. The difference, but to the permanent link, is if you look at the reference planes here again, here, so get used to it, and over here, they are basically excluding the first and last connector. So our testers have to mask out the first and last connector. That is important to remember later on when we talk about MPTL testing. Keep in mind. So, well, we don't need that anymore. Let's go. Yeah, we're talking about MPTL now. MPTL is a new cabling configuration. Basically, typical use case are access points or surveillance cameras, and basically it's like a permanent link, but on one side is a socket, on the other side a plug, and that's, from a testing point of view, a bit more of a challenge for testing for the testers, for the handheld testers, and we'll look at that in a moment. So you have, on one side you have the socket, on the other side the plug here. There might be also a consolidation point in between, so that can also happen in an MPTL link. And basically you test everything from the distribution point up to the device connection. In many cases, this plug here you see on the device end is a field terminated plug. So that also makes testing on that side really an issue, that your tester includes the first and last connector in testing. So you see where the reference planes are, they connect the first and last connector. So we do that with, on one side there's a permanent link measurement cable, and with a permanent link adapter, and on the other side of the link is a patch cord or MPTL measurement adapter. For us it's the same thing, because the patch cord adapters and MPTL adapters are basically the same thing, but for ease of use we have two different versions, calling one patch cord, the other one MPTL. So that's how they are tested. Important here is you cannot use channel adapters because they mask out the first and last connector. So in ISO, in EN, basically there's configuration A, B, and D for the one with only two connections, and configuration C for the one with consolidation point. Well, okay. Let's take a look at end-to-end links. That's also fairly new in cabling type. The application here is direct connections to servers, or connections in industrial environment between machines, in production plants, for example. So they can contain a lot of different configurations. Basically, one thing they all have in similar, they all have plugs at the ends. You could say, well, this is like a patch cord, but they can be up to 90 meters long and can be made of solid end stranded cables. And the big difference to a patch cord is they can have different segments. So you can have one segment with two connections, you can have two segments with three connections, you can have with three connections with or three segments and four connections. Basically, when you have a coupler that is shorter than 10 centimeters, you see that here at on the side, a coupler with shorter than 10 centimeters, it's one connection. If you have couplers that are much longer, basically with a piece of cable in between, they are seen as two connections. So that would be 3 segments and 6 connections. You can have 3 segments and 4 connections. You can have 4 segments and 5 connections, and you can have 5 segments and 6 connections. So you see lots of different configurations. they all have in common that the first and last connector must be included in the measurement, and they all have different limits. And again, here you find basically the all these limits in our tester. We choose to test those with extension cords. You see that here in the picture. Here's the 2-meter extension cord, measurement cord from the tester to the first connector in the link, and same on the other side. You can have on these links M8s, M12s, RG45s, IX, all kinds of different industrial connectors. So that makes it really interesting. You have lots of different limits and lots of different connectors to support. We do that, as I said, with 2-meter measurement cords because on one hand, it's easier to adapt to different connectors. And on the other hand, if you imagine you stand in front of a production machine, you have to have some kind of measurement cord to get to the point where you need to measure. So in a summary, we have the channel, the complete transmission channel. We have the fixed install track, that is the permanent link. We have the end-to-end links for machine or server connections, and we have the direct attach or MPTL as for access points or terminals direct connections. So 4 different cabling configurations basically. So how do I do now a correct certification? First of all, regularly check your measurement for wear and damage measurement device. That's because if you're on an installation site and you test a lot of different links, your connectors, your measurement connectors will wear. So you have to monitor wear and damages. You have to think about, do I have the right measurement adapters for my network? Do I have, if I do MPTL testing, do I have the right adapters for MPTL testing? If I do end-to-end link testing, do I have the correct M12 X-coded or decoded connectors or whatever? Sometimes you need to do a field calibration of the device, only if you don't use it for a longer time. You don't need to do that automatically every day or something like that, but sometimes every now and then the testers will remind you that they want to have a field calibration. You need to create a project in the testers. You have to select the data cable. You have to select the standard. There's a mistake in here. Apologies, we don't have EN11801 and ISO 11801. It's EN50173, obviously. Sorry for the mistake. We have to choose the correct cabling configuration, permanent link, channel, MPTL, end-to-end link. And of course, the required class is it E, EA, F, EA, class 1, class 2. And then press auto test. That's all you need to do to come to a correct measurement. What do we test? Basically, we test lots of NF parameters, wire map, for example, and the loop resistance, DC resistance. That shows you a lot about the installation quality. And we test delay and delay skew. That gives you some hint on the cables used. Then we have a lot of high frequency parameters. Insertion loss gives you a clue if the cable is okay. Near and crosstalk, far and crosstalk is not displayed. It's used for calculating ACR and ACRF. You see here on the side here. Basically, gives you a clue on the connectors, if the connectors are good, and return loss. Basically, gives you a clue about the interaction between the cable and connectors. Also, if you basically damage your cable during installation, gives you good clue if when the return loss has issues. And then we have a lot of calculated parameters. Length is calculated, of course. Length in ISO and EN standard is only an informative value, so that's not a pass-fail. Delay skew is a calculated value. Power sum values, power sum next gives you also again a good hint on the on connectors, if the connectors are good. And then we have the interaction again between components and cables. Calculated values are ACRN, ACRF, and the power sum values of that. Let's take a short look on remote powering. Why do I mention that here? Because remote powering today goes up to 60 watt, so-called PoE++. 60 watt in, sorry, that was PoE plus, and 90 watt PoE++. That is a lot of power on a small diameter cable like our LAN cables. So the 802.3 AF up to 12.9 watt was only very little power actually, but the BT up to 71.3 watts at the device on 90 watt at the power source equipment is a lot of power. You can see what happens on the right side here at the connectors here. When you pull 90 watt power under load, you get quite a bit of spark erosion. The other thing that happens actually is what you can see down here. If you have large bundles of cables like here, you get heating of the cables here. So from 60 watts onwards, 60 watts to 90 watts, we basically recommend to use DC resistance unbalanced measurement to ascertain that the resistance of the individual wires of the cable are good or within tolerances. So the reason for the DC resistance measurement again is the overheating of cables. That gives you basically DCRU gives you a good measurement on that. We also have further webinars on PoE, 4-pair PoE, so stay tuned on those. What else? We often get asked which copper cabling do I need for which application. So that gives you a little bit of an overview what kind of cabling you need to support an Ethernet speed. So the classical ISO 11801 or EN50173, basically the Class D and Class E supports 1 gigabit, Class EA supports 10 gigabit, and even Class FA up to 1000 megahertz supports only the 10 gigabit. If you look at N-base-T cabling, the TR11801-9904, that tests if Class D cabling can support 2.5 and 5 gigabit, and the 1181-9905 tests if Class E cabling can support 2.5 and 5 gigabit. There's a bit more to that. There's a lot of length restrictions in there and so on, but this only gives you now a very short overview. And of course, the Class 1 and Class 2 up to 2000 megahertz, up to 25 and 40 gigabit for up to at least 30 meters. An outlook on 25 gigabit. There works at the moment in standards to increase the range for category 8 to support 25 gigabits from 30 to at least 50 meters. The original 30 meters is a bit too short for office buildings. It's okay for data centers, but to give 25 gigabit more a wider customer base, 50 meters would be really better. So the new applications then would be high-speed wireless access points or high-speed tertiary cabling, basically. So that would be up to now. It's, as I said, it's the Class 1 2000 megahertz at 2000 megahertz up to 25 up to 50 meter in future. Yeah, another outlook would be single pair Ethernet. We also have seminars just on single pair Ethernet. Topics here is single pair Ethernet is very interesting for the automotive industry and also for structured industry and offices and industry. use cases in industry is robotics and sensors and actuators, and there's different lengths from 15 meters, 1 gigabit of over 15 meters, and up to 1 kilometer and 10 megabit. So 1 kilometer and 10 megabit Ethernet, that is a perfect application for sensors and actors and or slower speed surveillance cameras, for example. There will be a new amendment in ISO 11801 to support single pair Ethernet, and as well as in TIA 568. Also interesting in single pair Ethernet is there will be new connectors for MICE1 environment. So that basically is office environment. You have the 63171-1 connector. You see, you read here correctly, it's an LC mating interface. So the body of the connector looks like an LC, but it has two copper pins inside. And the 63171-6 for heavy industry use, so MICE3 environment. These are the two preferred ones in ISO 11801. There's also the 63171-5 connector, which is basically this gray guy here. And for the you also see, right, this is a terminal screw here. So for 10 megabit applications up to 1 kilometer, actually people also consider using terminal screws, and it actually does work. It's interesting. So we'll be back on 2 wires and terminal screws. So just a short outlook on single pair. If you want to learn more about single pair, have a look at singlepair-ethernet.com. It's the web page of this single pair Ethernet Industrial Partner Network, where Softing is one of the founding members of. We have a lot of information on that page. So a small commercial now on the WireXpert. You can test all these things with a WireXpert. So the horizontal cabling, Class D, sorry, this is still in German, apologies for that. Class D up to FA, MPTL cabling, coaxial cabling. You can test multi-mode, single-mode fiber with it. You can test up to category 8 in data center with it. We have a lot of accessories for industrial, M12, M8, IX, whatsoever connectors, and also in laboratories, adapters for VNA testing. So that was the commercial block. Thank you for listening into that one. So we do that with the WireXpert 500 as the workhorse. The 500 plus, it's a copper and fiber optic all-rounder. The 4500 is our flagship up to category 8, and the 4500 Pro, including the optional DC resistance unbalance adapters. So with that tester, you can test basically everything I've shown you today. And that basically brings us to the end of this seminar. We have many different other seminars on our webpage, and I would welcome you to take a look what else we can offer to you. And basically that's at the end of the presentation now. We come to the question answer part. Alex, do we have questions?
Again. Yeah, we have a much attendees with some questions today.
Okay.
One of that is some customer says they have tried to certify a permanent link cable and the results was fail.
Okay.
Then they tried to certify the permanent link cable adding 2 patch cords. That means channel. And they succeeded to certify the channel link. Is this logical? Is the channel standard more related than the permanent link standard limits?
Yeah, I mean, first of all, the channel limits are less stringent, so they are not so tough like the permanent link limits. And secondly, if you have a connector on the permanent link that is, let's say, not so good, right? And you add a 2 meter or 5 meter patch cable to it, you add additional attenuation. Sorry, we have a feedback at the moment. yeah, sorry. You add additional attenuation to it. So the additional attenuation on this connector together with the less stringent limits can make a link pass. But keep in mind, the patch cables that are used in the channel measurement must stay at that link. This measurement is only valid if that cable stay at the link. Yep.
Okay. The next one is a question about MPTL. Why is it necessary to use an adapter adapted to each particular class and not a generic class? For example, up to class EEA, like some manufacturer proposes?
Yeah. I wonder if I should show that again. Yeah, maybe I'll do that. Give me a sec. I'll pull back to the MPTL slide to show that more in detail to you. Sorry. I hope you don't get seasick. Here you go. You see that this first and last connector needs to be included in the measurement, and the standards say if you include that connector in the measurement, you have to test against a reference connector, and reference connectors are different for each category. So you have a category 5E, category 6, and category 6A reference connector. That's why we sell different MPTL and patch cord test adapters for each category of connector, basically. If you don't do that, you're not testing according to standards. Same as if you use channel adapters, for example, but maybe.
Okay. Another question is for end-to-end link measurements.
Yeah.
How do I measure an end-to-end link? On one side is an RG45 and on the other side is an M12 connector.
Yeah, well, you need the right adapters for it. I'll just show that slide on end-to-end again. Since in our tester we use 2-meter reference cords and basically mask out the cord from the measurement and just start testing at the beginning of the end and at the end of the link. We can use measurement cords with any connector on the end. So we have cords for where you can use RJ45 on one end, M12D or M12X on the other side, or IX connector on the other side. Basically, it's just a matter of matching cords. Be careful when you measure M12D. It's only a two-pair system to also define in the tester a 2-pair measurement standard, of course, measurement cable. Okay.
Good. Another one is about consolidation point installed on the link. There is a fault on a link, maybe a crosstalk next failure.
Yeah.
How can we find out where is the fail when is a consolidation point installed?
Okay, again, back here, you have the consolidation point here. So the question is, if I have a failure on this side here of the link, how do I know if it's this connector or this connector? The tester will only say it's failed on the near end or failed on the far end. We recommend to use the locator function in the testers. With the crosstalk and return loss locators, you can locate along the link after after how many meters of that link you're going to have a fault. So that's perfect to actually discriminate if is it the consolidation point or is it the end of the link, or maybe somewhere else. I mean, if you pull too hard, maybe you also damage the cable and you get return loss errors along the cable, basically.
Okay, good. I think that's all for today.
Good.
Thank you for the presentation.
Thank you. If you have any questions, I'll just pull up the last slide. Sorry again hope you don't get seasick. If you have any questions, you can contact me anytime. Give us a call. We'll follow up. And many thanks for listening in today. And I hope to see you again soon. Thank you and bye-bye.
Thank you. Bye-bye.